So here's our unit circle again, and now it's fully populated with all the angles and all the trigonometric ideas that we learned so far. And how you read this thing is you look here first, for example, at 120 degrees or 2 pi over 3, this is your angle. And that would be your angle from here to that line. So that's 120 degrees, or 2 pi over 3 if you're going to write it in radians. And then in the parentheses, this is the point here. This is the value of the point here. So this is your x and your y. So this is your point pair associated with, and remember, sine of alpha equals y and cosine of alpha equals x. So again, as we said before, if we wanted the sine of 120 degrees, we would just figure out what this x value is, and it's square root of 3 over 2. We could just look at this unit circle chart. It's pretty easy to memorize once you figure out the pattern. For example, let's do the cosine of 135 degrees. Well, again, we start here and we spin around 135 degrees. Well, it's written 135 degrees here. It's actually the very next point on this. So the cosine equals the x value equals minus square root of 2 over 2. Go ahead and check this with the calculator. How about the sine of 315 degrees? Well, it's going to equal the y value of the point. 315 degrees, we spin around all the way to here. 315. That's the same thing as the sine, or equals the sine of 7 pi over 4 radians. And the y value equals minus square root of 2 over 2. It's the same thing as that up there. That was just a coincidence. Notice we can do something else here. We don't always, well, actually before I do that, what about the sine of 390 degrees? This thing only goes up to 360. So how do we get the sine of 390 degrees? Well, we spin all the way around once to 360, and then we go 30 more. So this is 390 degrees. So the sine of 390 degrees equals, again, sine always equals y, the y value, and the y value here equals 1/2. Let's check that in our calculator. I've got degrees, sine, 1/2, value 1/2. So these are periodic functions. So every time you go around 360 degrees, you start repeating the exact same numbers all over again. That goes on for infinity. Okay, now another thing we can do here is, what about the cosine, say, of minus 60 degrees? So the angle now is a negative angle. Well, this equals minus 60 degrees. Again, we start here, but we go this direction. So 360 minus 60 is going to be at this 300 mark. So it's the same thing as the cosine of 300. And this is going to be x. And everything's just turning out to be 1/2. It's just a coincidence. Again, we'll check this with the calculator. Minus, okay, let's clear this last one. Minus 60, or 60 minus trigonometric cosine equals 1/2. So you can go in either direction. So sometimes it's easier, instead of going around almost to the 360 mark again to come in the other direction and just take the opposite of what you want to do. So instead of cosine of 300 degrees, you could do the cosine of minus 60 degrees. So the unit circle is a convenient way to learn your sine and cosine functions without having to memorize these. When I was in school, when I was your age in school, I had to memorize a table of these things. We didn't use the unit circle. But unit circle is a nice way to go now. So you don't have to memorize this stuff anymore. You just have to keep in mind the unit circle. And if you forget the value of these things, you can always just go to Google and type in unit circle and bring it up. So one last point is we can easily, okay, suppose you have a triangle like this, where you don't know what this angle is, but you know the length here is 2, and you know the length here is 9. Well, that's not a unit circle anymore. Well, we can still use the ideas of the unit circle to help us out here. What we can do is we can redraw this triangle as a different triangle, but it's a similar triangle. And notice, we recall here that cosine of theta equals adjacent over hypotenuse, or 2 over 9, which was adjacent over hypotenuse. We learned that in the last section. Well, okay, let's make a similar triangle now using this value. If that's 2 over 9, why don't I make this 1, this length 1 here, for r, so I can use the unit circle, and this length now 2/9. So now, theta is still the same here because these are similar triangles. Theta is the same. I say the cosine of theta equals, since this is the unit circle, I know that equals x, and this is y. So sine of theta equals, well, I know this is x, so this is 2/9. It's going to equal the same thing because it's the same angle. So now, how do I figure out what this is? Well, recall the Pythagorean theorem that said, essentially, a squared plus b squared, the two shorter sides, a squared plus b squared equals c squared. So in this case, c squared is 1, a squared is 2/9, and b squared we don't know. So really what we're looking at here is x squared plus y squared equals 1. Or we could say that the cosine squared of theta plus the sine squared of theta equals 1. This is actually what we call a trigonometric identity. But you don't have to know that. But do understand what we got going on up here. So this leads to b squared, or y squared, equals (1 minus 2/9 squared). 1 squared minus 2/9 squared. So, therefore, y then, that's what we need to find for sine, y equals the square root of 1 minus 2/9 squared equals, well, 1, this is going to be 4/81. You have to square the top and the bottom. So let's make this 81/81. So this equals 77/81, or the square root of that. We can pull out 1 over 81, which is going to be 1 over 9, times the square root of 77. That's what y is. That's what the sine of theta is. 1/9 times the square root of 77. So that's a little more complicated than what we were doing before, but that's another way to use this unit circle idea. So you don't have to even mess around with calculators.